Today we will learn about cell design of SRAM. What is 6 transistor SRAM cell? A 6 transistor SRAM cell is a most widely used memory cell in modern processors. It stores 1 bit of data using 6 CMOS transistors arranged to form a stable latch. These 6 transistors work together to store data, read the stored value, and write new data into the new cell. The 60 name comes from the fact that exactly 6 MOSFETs are used in a standard SRAM cell. The cell consists of two cross-coupled CMOS inverters that act as a storage element and two access transistors that connect the cell to the bit lines during read and write operations. The access transistors are controlled by the odd line. When the odd line is activated, the cell is communicates with the bit lines. When it is inactive, the cell remains isolated and continues storing the data. Here, why does SRAM require 6 transistors? Each transistor is an SRAM cell has a specific function. The 6 transistors work together to reliably store and access data. The first 4 transistors from 2 CMOS inverters. These inverters are connected in a feedback configuration so that they continuously reinforce each other's output. This creates a stable memory element capable of storing either a logic 0 or a logic 1. The remaining two NMOS access transistors act as switches. They connect the storage nodes of the cell to the bit lines only when the odd line is activated. During read operation, they allow the stored value to be sensed by the bit lines. During a write operation, they allow new data from the bit lines to override the existing value. Without these access transistors, the memory cell would always be connected to the bit lines, making reliable storage impossible. Therefore, all 6 transistors are essential for stable operation. Here, what is cross-coupled inverter? Here, a cross-coupled inverter is the heart of the SRAM cell. It is formed by connecting the output of one CMOS inverter to the input of another inverter, while simultaneously connecting the output of the second inverter back to the input of the first. Here, this creates a positive feedback loop, allowing the circuit to maintain one of two stable states indefinitely as long as power is suitable. If one storage node Q is at logic 1, the other storage node QB automatically becomes 0. Similarly, if Q is 0, QB becomes 1. Here the two inverters continuously reinforce each other, preventing the stored value from changing unless an external write operation forces a new value into the cell. The bistable behavior is what makes SRAM static, unlike DRAM which relies to the on charge stored in a capacitor. Here the SRAM stores information using the stable feedback mechanism. How does SRAM stores 1 bit? In an SRAM cell stores 1 bit of information using the two storage nodes Q and QB. These nodes always hold opposite logic values because of the cross-coupled inverter structure. When the stored bit is 1, the node Q remains at a high voltage logic 1 while QB remains at a low voltage logic 0. If the stored bit is 0, Q becomes low and QB becomes high. Since the two inverters continuously drive each other through positive feedback, the stored data state remains stable without requiring any refresh operations. During normal operation, when the load line is low, the access transistor remains off. Isolating the cell from the bit line, isolation ensures that the stored bit is prevented until a read or write operation occurs. Why is the stored data is retained? Here, the stored data is in an SRAM cell is retained because of the positive feedback created by the two cross-coupled CMOS inverters. Each inverter continuously drives the input of the other, reinforcing the stored logic state. If Q is high, it forces QB to remain low, and QB being low forces Q to remain high. The self-reinforcing action creates a stable equilibrium. Unlike DRAM, there is no capacitor that gradually loses charge over time. Therefore, the stored data does not need periodic refresh operations. The data remains unchanged as long as the buffer supply VDD is present and no write operation is performed. However, SRAM is still classified as volatile memory, which means that if power is removed, the feedback loop stops functioning and the stored information is immediately lost. Here the key points is data is maintained by positive feedback, no refresh operation is required, storage remains stable while power is on. Data is lost only when power is removed or during a write operation.